Hello, everybody. Sometimes when this goes on YouTube, this bit's in, so it's like a little pre-show. So we are now live. So I'll play that intro and then we'll get going. Here we go.
Let's do it. It's go time.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about avoiding bloat. Yes, indeed. I'm joined by Egon Elbre. Hello, Egon.
Hello, Matt.
Welcome back to Go Time.
Yeah, it's nice to be back.
It's nice to have you back. And you build things at Store J, right?
Yeah, storage. So
Is that how it's pronounced?
Yes.
Yeah.
That's the first question I always get.
Yeah.
But
GIF or GIF all over again. GIF or GIF. Yeah. Well, welcome. Yeah. We're also joined by Roger Peppe, hacker at qlang.org. Hello, Roger.
Hello, good evening.
Good evening. Welcome to Go Time. We shouldn't say good evening because we don't know when people listen to this podcast. One of the great things about Go Time is you listen to it on your own terms.
It's always the morning on the internet. Good morning.
It's always the morning somewhere on the internet. Well, people do terrible things in the morning then, in that case. Okay, well, yeah, okay. So we're talking about, before we get going, Egon, I was interested, what have you been working on lately? Anything interesting?
So one of the recent things I finished was a project called Lensen, which allows you to browse source code and to compile the assembly side by side and see how code translates into assembly, essentially, and kind of do this interactively and kind of a nice way to visualize it when you're optimizing things.
Yeah, very cool. Because it's funny, like a lot of people, I think, stay at the code level and don't really dig into that. And it's quite apt for this conversation about avoiding bloat, like understanding what's this turning into.
Yeah, exactly.
Yeah. And Roger, Qlang, very exciting project. What's going on there?
I think it's an extremely exciting project. Yeah. So I've been involved with the language Q. I've been enthusiastic about it for a few years now, two or 3 years, since not so long after it came out, and recently had the opportunity to join the project. So I'm now working on it full time.
Amazing.
On this language, on this new language, sort of halfway between JSON and a normal language, I suppose. Configuration language with some very, very interesting properties. It's a very cool project, and hopefully should be useful for everyone now, but in the future.
So keep your eyes out. Well, we'll put a link to it in the show notes for anyone that wants to dig in more, and maybe we'll do a different episode on that at some point, Roger.
Cool. It's a great idea.
And Roger, you also play the fiddle, don't you?
Not relevant here, but yes, I do.
Very relevant, because I went to a party once and I thought I was having a stroke, but turns out there was a man playing a fiddle. That was you.
Oh, that was me, was it?
Yeah.
Oh, really? I was at the same party as you. Gosh, there we go then. I'll try not to do it again. Yes.
Yeah. No, do it. I've never been. There's barely anyone ever playing a fiddle at any parties I go to. So
you just go to the wrong parties.
Apparently so. Okay, so let's get started then. When we talk about bloat, what do we mean? What is bloat?
So I like to kind of separate it to code bloat and binary bloat. So one is like your code is growing larger and larger, and the other is your binary, the final deployment thing, growing larger and larger. Right?
Yeah. Okay. So we'll bear those two things in mind then as we have this conversation, because I think I can see them both. They're both important to pay attention to in different places. And so with code bloat, like one thing that is you can have like relatively small amounts of code, but if you have lots of imports, your binaries might end up being quite big, right?
Yeah. So I actually took up some statistics, and I like to do some small quiz, right? So how much would you guess how many lines of code would, if you import the timestamp protobuf definition and just print it out how many lines of code would that cause? Like marshalling it and like how many lines of code would it import?
In Go, if you imported,
Yes.
Oh, it can't be many, can it?
I reckon my guess would be about 30,000.
What?
I know that protobuf is ridiculously bloated, so that's my guess.
I thought it was all about being tiny little payloads. I was gonna say 50. I feel like this is a good quiz.
No, it's 27,000 lines of code.
Oh wow.
Yeah.
Roger,
So
how did you get that so close? That's suspicious.
Order of magnitude. Yeah, no, Egon tipped me off.
Yeah.
He didn't. He didn't.
No.
I just know how big these things are.
Okay, the other common one is gRPC. Let's take.
Yeah. Oh, well, I know that's a binary format, so that sounds small. A billion. I've learned my lesson.
gRPC is, well, that includes all of protobuf 2, right? So
Yes.
we're talking like
It's going to be more
maybe
than
120,000 lines of code.
In the same ballpark, so 100,000.
Roger is suspiciously close to these. Do you
I
count
had too
lines of
much
code?
experience with large code bases.
Yeah, apparently. So, but that tells you something though, because it'd be very easy to just build what you imagine to be a very small project and just import one of those two technologies, and suddenly you're really talking serious numbers.
Yeah, compared to NetRPC, if you remember that package that not many people use, which is only about 1,000 lines of code, a couple of thousand lines of
something
code.
like that.
Is that why people don't use it? It's not enough. People like, I'm not buying it unless it's got loads of lines of code in it. No.
I mean, the gRPC also has its entire copy of the HTTP, another copy of the HTTP2 stack and that kind of thing. So it seriously reinvents many wheels.
So would you have to import that to use it in a project, or is that just like the tool chain needs that?
No, the code that you import and the compiler has to parse through, essentially. So,
well, you just don't notice because Go's build times are they're so fast. Maybe we're spoiled by that a little bit.
Every single line of code adds 1 second to your build time. So,
well, that's what it used to do. That'd be good. Well, you'd pay attention to code bloat if that were the case, wouldn't you?
I think it's all just got so ridiculous from my point of view. You know, it started off back in the 80s where like like 16K was a huge amount, was a very large program, and now it's on the many hundreds of megabytes, and like, well, does it matter? What does it really matter? I don't know. I don't think it does. Like from my point of view, I think unless you're really coming up against build times or against the binary sizes, what's important to me is the maintainability aspect of code bloat, and how it's about the bloat in the code that you maintain, not necessarily the bloat in the code that you're importing.
Yeah, right. So that's the other side of this then, is as projects grow and grow, you have to maintain that. Sometimes you can just leave code for ages and you never really have to touch it, but you still have to, you still have the cost of maintaining that, don't you?
Yeah. I consider every single line of code that you import that you are the maintainer of it now.
Yeah. Every line of code.
Because maybe the maintainer goes on vacation and you have a critical bug that you need to fix, right?
So you've personally reviewed all those lines of gRPC code?
Yes. And
Good
luckily
work.
I don't have to do it anymore.
You do that every time there's a new release? Or just read the diffs and then apply that in your brain?
No, we dropped actually gRPC for that maintaining reason. So,
Yeah. So that's interesting then. You sort of, when you import a package, I think it's because it's such an easy thing to do. I wonder how many people think I am kind of committing to also taking on the responsibility of looking after this entire other project as well. I don't know that many people have that mindset, do they?
I think it depends on the background where you come from.
Mhm.
So if you like start out by building websites and like all that stuff, then probably you don't think about it. I used to work for an electronic medical records company, so there every single dependency had to be like thoroughly reviewed and like whether it's suitable, and so
Yeah, for sort of regulatory reasons, I guess.
yeah.
Yeah.
So
Yeah, I have to say that I don't personally review all our dependencies because I don't have the time. But if I take on a dependency, I look at the dependencies of the dependencies often. You know, I'm almost more concerned about that. If something just depends on the standard library, I feel that I've got a handle on it. But if it's depending on other projects, then that's a bit more problematic. In projects that I maintain, I try to keep the amount of dependencies, particularly when it's a library that some people are going to use, like the few I maintain, and I just try to keep the dependencies absolutely minimal if possible.
Yeah. So how do you do that? Do you have to manually go and look at all the projects?
I look at go.mod actually, and I'm like, why have I got that dependency? Do I need that dependency? How can I strip it out? Which actually, and I was doing that a while ago with some fairly large code base. Why have we got this? And I came across, that was actually probably what ended me up with me and this call actually, because I came across Egon's tool Goda, which is like a fantastic way to try and visualize, to see why you are using a particular dependency and how you might be able to hack it out.
What is that project, Egon?
So it was kind of for solving this problem of understanding your dependencies. So it stands for Codependency Analysis Toolkit. So I ended up kind of collecting these different tools, and then I eventually merged them into a single, like a large bundle of them. It's at github.com/LOOV/GODA. So
Yeah.
and it has kind of features for I try to explain it as you do calculations with package sets and dependencies. So you can kind of start removing things that you don't care about in the package list or graph. And then you can kind of drill deeper and figure out like why is something being imported. There's also a subcommand Goda cut that displays packages that you might be able to easily remove because they don't have many incoming dependencies to them. So, so a bunch of tools, I guess.
Yeah, that sounds really good. I mean, as a rule, I kind of agree with you, Roger. I'll try and if I'm going to import a package, I'll prefer ones that have just a few dependencies. And even sometimes I used to just like copy bits of the code in, and with the license at the top, always, because just to kind of avoid it. And often there's like lots of tests, maybe something in the testing side that is. Testify has quite a lot of dependencies. Is that okay? Like, would you avoid Testify for that reason, or because it's in the test side? Are you all right?
Personally, yes, I would. But I'm biased, right? Because I maintain a package called I'm trying to think what it is now. Quick Test.
Yes.
I'm one of the maintainers of that, which does not have many dependencies and is kind of a bit smaller. So I quite like that because Testify has lots of dependencies. But it's hard to avoid them because some dependencies are really useful, right? Like a diff, something to print out, to print out diffs, for example, like the CMP package is great for that. But it's another dependency. Right?
Yeah.
I do that when I bring in dependencies. I actually do review most of the lines of the code, and I also run our usual linter suite through the code base. And this means that if we import a new package, usually there are a few fixes that we contribute upstream already. Like maybe there's a data race, maybe there's a global variable that can be removed, or like many kind of maybe minor things, maybe major things, but like so.
The other thing that the Goda tool is really useful for, I've found, is trying to sort of code bloat, which we haven't really talked about, is code bloat in your own code base. Like, so when your code base gets really big, and maybe you've done some changes, and you've made some big migrations, but you've still got some old bits of code, and just trying to make sense of this tangle of dependencies, that you end up with something if you have more or less a monorepo. Then you can have a very tangled set of dependencies, and it's really quite hard to make sense of them somehow, and to try and work out, okay, we want to factor these things out into their own thing, but you don't know where everything's coming into it, what's coming out of it. And I found that incredibly helpful when I was making some changes, particularly to the recent in my previous job at Influx Data. You're trying to do some big code changes, and it was quite hard to work out the dependency relationship. Of course, Go is fantastic because of a great rule that it has. You can have no cyclic dependencies, and that is amazing. Actually, with that rule, just in itself, has contributed hugely, I believe, to the maintainability of larger Go code bases, because without it, you tend to get in this situation where something at the very top, very bottom of the dependency tree tends to point to something quite near the top, and then you have this big ball of mud, which it's like a Gordian knot, and you can't cut it, right?
Yeah, so for people that don't know, this is where you'll have to say 3 packages. A imports B imports C, that would be fine. But it's when then C imports A, and you get this kind of strange circle, right? Is that right?
Yep, that's it. And also, like, it's a really good rule, but it was also really frustrating at times, because there are times you're like, oh, damn, we need to import this from here, and we can't, right? Because it says cyclic dependency. So then you're like, well, then you have to break your dependencies, and you have to, like, often you have to split up a package, but it's not clear how you can split up the packages. And it's actually quite a hard problem, but you're quite often forced to make this decision earlier than you would in some other languages, I think.
Yeah. And that's the thing. It's like, take on the pain early. A stitch in time saves 9, which means if you can stitch with 1, do it early, little bit of pain, saves that, because it grows and it becomes much more painful later. I've had the same thing too, and one of my approaches is actually just to keep everything in one package for as long as I can, as long as I can get away with it. I'm not joking. That genuinely works too. Like, because of that, and also I quite like it when the structure emerges rather than is kind of imagined, because sometimes it's obvious, and sometimes I've got like dependencies that, or I've got something that I want. I know it's going to be a package. I know it's going to be useful in multiple places. But I'm often surprised as well, as the application is being built, which bits kind of present. I certainly don't follow like just a standard structure that I know some people do.
I agree with that. Yeah, definitely.
So with binary bloat, then, like you said, 16K used to be a kind of big program. And I remember, a floppy disk was 1.44 megabytes that you could fit on that. If you take a photo now and share it, like, that's about 8 floppy disks or something, at least.
Yeah.
You wouldn't tolerate that if you're like, oh, you've got to check out this photo. Here's a little stack of floppies.
Those were big floppy disks as well, right? Started off at like 200K if you were lucky.
Yeah, when they used to be actually floppy.
Yeah. Not to
Yeah.
mention tapes.
Yeah. Oh no, honestly, I love that early tech. I really miss it when tech was rubbish because it was so cool. Like I had a Spectrum and with the tape cassette thing when I was a kid. So literally, and people won't believe this, but in order to load a program, you put and I mean like I don't even know if they know what a cassette tape is either. So it's something that you sometimes see on retro t-shirts. One of those. Literally, then it was the sound. It was encoded as sound. So it would play the sound off the tape, and that would, how a modem works, really. And then it would read the data, load the program, often with mistakes. So you'd need to do it a couple of times to get it right.
I think you now need to explain the modem as well.
Yeah, this is it. No, it's all changed so much. And by the way, I started young. I'm not old. Just want to make that clear. So, but why do we care about binaries now? Because we can get away with great big binaries, can't we? And what's the big deal? They upload in no time. They move around the web pretty quickly. Do we care about big binaries?
I think mostly we don't. Like, if we did, we already would have done something significant about it. But there are definitely cases where we do care, right?
I do get shocked by the size of binaries sometimes. I look at it, it's
Yeah.
like, oh, I'm expecting like 5 megabytes or something. It's like 120 megabytes.
Yeah.
Like, wow, that's ridiculous.
And is that usually because you've imported something in your own program, or you just talked about anyone's programs?
I guess I'm just talking about building a binary and having a look. It's not me importing something particularly. But yeah, but binaries are very big. I mean, I care more about binaries when if I'm on small devices, like if I'm running something on a Raspberry Pi, or actually even on a Raspberry Pi, you've pretty usually got quite a lot of SD card space. It probably doesn't matter either. But on smaller devices than that, then it really becomes an issue.
How many floppy drives can you attach to a Raspberry Pi?
How many floppy drives have you got?
Not enough. None
Clearly.
at the moment. Actually, I do have one because I recently I've decided I'm going to buy all my old computers that I used to have. So I got a Spectrum already. It's arrived. I've ordered an Amiga 500, and I'm bidding on one on eBay, an Amiga 1200. These were like my early computers that I kind of grew up with. So I will have some floppy drives.
That's a good idea.
Yeah, I'm just going to put them on the wall. Plug them in, but just have them on the wall. Yeah, okay, so sorry.
I should get an Egon Archimedes again. That was my first ever computer that I owned.
Did you? That is cool. Yeah. We had those at school.
I started on a 286, so I guess a bit later than you.
Yeah. What are you trying to say?
I started later.
Well, then you did a fine job. Okay, so small devices. Yeah, and this is kind of where TinyGo comes in, because this was the problem that TinyGo is trying to address, is that so that you can still use what is essentially like the standard library, but it's much smaller. It's deliberately designed to be cut down and simpler, isn't it?
Yeah, I love TinyGo. I use TinyGo a bit gratuitously. A friend said, I want to build a doorbell with like hanging not tubes. What do you call them? Oh, maybe call them tubes. With
tubes.
knockers dinging them and stuff.
Let's stick with
tubes. I built him. So I built him the software. He built the hardware. Like he put the actual thing together with the relays and that, but he never actually got the tubes working. So I built the software, and it's great because you got this tiny little microprocessor. Like it's maybe it was 16-bit, maybe 8-bit. I can't remember. Pretty small with like 1K, 2K of RAM or something, and you could build this Go program, which you can use Go routines and everything, right? So I just had this like separate Go routine, which would be responsible for going through the tune, and then another one which was listening to interrupts, where you would, you would press the bells and it would interrupt that other Go routine. It was a really nice way to structure it. You couldn't have done that if you were writing in C. Really, and it was great, and it all fitted. Like it was great. It turned the LEDs on in the end. It didn't ding the bells, but you could pretend.
Yeah, you could have a butler hire somebody to, when the lights come on, they hit the tubes
at the same time. That would,
if
totally
you could.
work.
Yeah, eventually work the way up to that. That sounds cool. I love that. And Egon, in the GopherCon EU in Berlin recently, you were hacking with TinyGo, weren't you?
Oh yeah, I did some MIDI controller thingy. So
yeah, so he was playing music on he had these buttons attached to this little breadboard, and then wrote the code to translate that into MIDI instructions for some music software.
Yeah, it worked pretty well, and it was really nice.
Yeah,
I did get some embedded device noise on it, so like some of the buttons didn't work as it's supposed to, but it still did things, I guess.
Yeah, it was like going doing, 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 which I think is good.
Yeah,
it's not as good as Roger on the fiddle.
The not so noise on that, I'm afraid. It was actually great using Go with TinyGo, because you could have this debouncing code, which was totally didn't care about any of the other code. We just sleep for a bit, wait for the debounce, and that was independent of all the other logic waiting for buttons and stuff. So
what was that doing then? The debounce, literally stopping if you got noise coming through from buttons.
Yeah, well, so if you press a button, then you don't. It's not a clean thing that you have pressed this button. There's usually the contact. It makes contact and then bounces and comes down again and bounces and comes down and eventually ends up either down or up, right? But you don't know when that initial contact is made which way it's gonna end up. So you have to you don't want it to go blah, 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 blah,
no
like that.
Yeah, you'll stress the butler out.
You don't want to do that.
Yeah,
I did have debounce code, but something was wrong.
Well, that's funny because debounce, I've used that in the front end of web development, which is literally same thing, which is if you click too many times, or sometimes on hover, like, because you can if you're just teetering on the edge, on the precipice of the pixel, you can end up with this horrible flicker. But in your case, Roger, that is literally a bounce that you're talking about.
It is absolutely literally a bounce. Yeah. It was quite interesting to write, and you could just write. So nice writing it in Go, honestly. Can't get over how nice it was. You even have like interfaces. You have they're quite clever about interfaces in TinyGo, actually, because they basically expand all the code out. They're really clever about some of the optimizations for space in TinyGo.
Yeah. Do you think like people should, as an experiment, like use TinyGo and try and actually experiment with that, and also like run something on a tiny device just to sort of understand what's going on? Or is this, again, are we just at the point, most people, where we can just deal with the big binary?
I think it's well worth experimenting with it and having go see what it takes to run in 1K of RAM or whatever, because binaries are still quite big, but you can still have like 128 256K of binary, but you're not going to be importing gRPC. But the other place that binary bloat really matters is on the web, right? So if you can compile Go to WASM, but if you're downloading 100 megabyte WASM file, to your browser, that's not going to go so well.
Yeah.
So, and that's actually, I think, I haven't used it in this, but another use case for TinyGo is to target. You can target WASM and have a relatively small binary that gets downloaded to the browser.
Yeah, I've seen that. I've never done it myself, but I saw a talk, which I'll try and dig out and put in the show notes, of somebody that basically did that. They wrote something just in Go and showed you how long it took to actually run, and then because it has to download into the browser, and then they did it in TinyGo, and it was obviously much snappier. And it's very cool. And I think WASM, like, I'd love to see. I think there's an interesting future there with WASM, and I think therefore TinyGo probably does play a big part in that for Go people. I know that Ron Evans, who one of the main contributors and I think the founder of TinyGo, he very much advocates for more people looking at TinyGo and using it and contributing. So he's very keen to get people on board with it as well.
Yeah, it's really cool. Actually, an interesting observation is that in the smaller Go programs, one of the main contributors to binary bloat is the FMT package, the FMT package, because that actually is quite big, and so many things have it as a dependency.
Yeah, and it feels like something that's just baked in to the standard library and therefore is just around and you can just always use it. But if you think about all the things, when you use the verbs, like all the different things you can do, the reflection and everything, you can see why it ended up having lots of dependencies.
It hasn't itself got lots of dependencies, but it is itself quite a large amount of code. Does a lot of reflection code.
So I think one of the major contributors to FMT package is actually Unicode tables, because it needs to handle many of those cases, and those. I think those tables were something. I might be wrong, but like a few hundred kilobytes or something already.
Yeah,
I'm not sure. I don't know. Maybe white space. I'm not sure.
What do you mean white space? Can't surely it's not padded out, is it?
I mean, it's 3,500 lines of code.
Oh, because of the quiz, Roger. You've got Egon back.
I mean, maybe scanf. I don't know. I'm not sure that that FMT itself needs those Unicode tables. Maybe it does.
Maybe it has changed, but
yeah, I don't know.
I remember optimizing those at some point.
Yeah, I mean, I often when I was doing some of this stuff, I was like, I just want a version of FMT that only has like the very basic verbs like %s, %d, doesn't even do widths, and you'd be fine in most cases.
Tiny FMT.
Yeah. Tiny FMT, absolutely.
You
can't replace standard library packages though.
Yeah. Well, you probably can do anything you like if you have some kind of pre-processing thing going on. I'd actually genuinely like if it scanned to see which verbs you used and then built a FMT package that just had that. I don't know. It's maybe going too far.
I mean, that's kind of almost what Rust does, actually.
Is it?
Because in Rust the formatting stuff is macro processing, so it kind of expands out at compile time.
Ah, yeah, that's cool.
That's why the compiler is so slow.
Yeah, that's it. It's the trade-off you've got to make, isn't it? That's the thing about, I think, Go. Like, I'm always quite pleased with the trade-offs that they end up making. Like, so I understand, and then someone will hit an edge case and they're really frustrated by it because it doesn't, it's not performing for them. But by and large, I think they are pretty pleased with where they usually land.
Yeah, me too. And it does seem to be. It is maintainable for large projects, but there is that kind of inherent complexity that you tend to accumulate when your project gets larger and larger. And there's some threshold at which you kind of seem to cross, at which people stop understanding the code base. And that, I think, for me, that's really when code bloat, as I care about it, really kicks in. It's that people are making changes, they don't understand the code base, therefore they tend to reinvent the wheel or just write much more code to jam their feature into the code base, rather than seeing, oh, well, actually, we could just change this little package over here to add this feature and not add these 100,000 lines of code over here. And then you've added those 100,000 lines of code, and it's even worse, right? And for me, I think code bloat is quite strongly linked with technical debt.
Yeah, I think whenever you end up with bits of the system that you just don't touch. Like, no, don't go and touch this. Like, don't be scared of this. I think, it's very. I've had that situation before, and even in projects where I've been the only one working on it, I just managed to get something right, and I don't have the context, and it's messy. I never cleaned it up, and then I just don't want to even touch it. And with Go, I find that I do less of that, particularly because testing is such a big kind of first-class concern in Go, and I tend to write TDD, so I will, at the end of writing and solving a problem, I can just go back and just very boldly hack away at it, change it, make big changes with the confidence that as long as the tests are passing, then all the promises I've made are still true. And
I mean, that's great until you find that all the tests that you've written are using mocking, and that you're changing some of the things that they depend on, and so all your tests are now invalid, right? Because this this can be very hard.
Yeah. I think strategies like when you keep the interface near where you're going to use it, like that as a rule, I quite like. So some packages they'll expose interfaces, and I like the idea. Like if I'm going to use like the SendGrid API, if I have a sender interface that just has the single method that I'm going to use in there, like this to me, it's not really solving anything to do with code bloat, but I'm really explaining there that I'm only going to use this. This is what I care about, this piece. And then if there's any mocking or anything like that, then it's much smaller. But yeah, I tend not to do much mocking. I tend to do a lot more integration testing.
Me too, and I think there's a good reason for that, because if you have integration tests and then you refactor the insides to maybe use something with less dependencies, or something with a different kind of API, then your tests are still valid, right? But if you rely entirely on substituting in something, the thing that's underneath, then you can't change the tests, because you can't change those dependencies because your tests are now invalid.
Yeah.
And I think this is a big part. This is a big problem with larger code bases and being able to refactor so that you are changing your dependency network, for example.
So a question: what's your definition of technical debt? Like, I think many people use it. I've seen it used in many different ways, and I wonder what's your definition.
Mine or Matt's?
Both, I guess, if it's different.
Might be different.
Yeah.
Well, just off the top of my head, I'd say it's something that I should have done now, but I'm not going to. Things that, you see, I tend to avoid it kind of quite rigorously wherever I can. So I'll go to great lengths to either, usually by shrinking scope, but I'll try and not do as much, and then I can do it well. But that's a very vague answer. I don't know if that resonated with you, Roger.
I mean, for me, technical debt is something that is like a cost that I'm unwilling to pay, or I was unwilling to pay in the past, because some greater priority meant. Because you've always got to prioritize, you've always got to triage and do some things first and other things later. So technical debt is the things you left for later, right? And that you can pay that off early, or quite often it's like, well, the other things are still more important, so we'll leave that, or this is really too big. This is actually going to we're going to have to take an entire year out with our whole team in order to address this serious problem in our code base, and that will take us out of the market. We're not going to do that. Will mean we can't ship any features. So this is a debt that you're not going to pay off, and you probably will never pay off, and that's the death, I think, of most projects.
It's like a mortgage. Mortgage, actually, the word comes, it's like death loan. The mort in mortgage comes from death.
Oh.
Yeah, really. Because that was the idea. It was you just have this loan for your whole life. Sounds grim, doesn't it?
I never knew that.
So at some point I was thinking about technical debt, like trying to give it a rigorous like answer, like what is it? So what I ended up is that, let's say you put there's some effort that you put into maintaining a code base. Like it doesn't need to be maintaining, but maybe there are other aspects. And then there's the like ideal state of how much effort you need to put into the code base to maintain it, right? So the difference between those ideal state and your current state is going to be the technical debt, right?
So that sounds reasonable.
Yeah, but there's one funny thing there. Let's say there's an innovation in the technology, right? Let's say when React came up, right? The ideal maintainability or the effort to maintain got lower, which means that your technical debt goes high up if there's an innovation. So
that's interesting. And does that mean that when you start a project and it's not by any means finished, that you just like that counts as technical debt because you just haven't finished that project that you've just started?
Kind of, yeah, I guess. Like, so there's it depends on like what you can say that you have let's say you have a security debt, like you haven't done a proper security audit, right? Or there are other aspects to like you can measure. And if you look at maintainability only, then an unfinished project isn't necessarily in debt because of its being unfinished, right? So the ideal state in terms of maintainability, right?
Yeah. So that is interesting. So in that case, because this is the other thing, if you have what you perceive to be a technical debt and you acknowledge it and you decide for priority reasons, we're going to leave it. And then later you find out we actually didn't need that. We never need it.
Yeah.
Then I guess is that just pays off. It just kind of gets written off the debt. Yeah. And so I think one of the other principles is like designing things so that you can change them, designing things for that flexibility in the future, I think is quite an interesting idea that I saw it on Twitter. Somebody said like architects are there and it sounds great because it's like designing these systems and they are laying these foundations and telling you where all the important pieces are going to be. And then someone said, if you called those people like technical, forget the term they used. It was something like technical early decision, like unchangeable decision person. Like suddenly this sound really unreasonable and that you wouldn't want that. So having like flexibility in the architecture and being happy to change things and evolve things, I think. Acknowledging that we don't know stuff, we don't really know anything at the beginning, especially, and we'll learn it as we go.
That said, I think it really helps to do a lot of thinking through because you can actually design stuff. It might not be set in stone, but I do think that you can eliminate a lot of bad code paths or bad futures by just thinking them through to start with and thinking, well, if we went that direction, where would we end up? Like that's a bad place to go. So I think a lot of people are like, we shouldn't do any design up front. And I really don't agree with that approach at all. If you look at Go, for example, they designed a lot. They wrote the spec before they did the implementation.
Yeah, of course. Yeah, and
I think there's like there was one code that you when you're designing things, add flexibility into the places where you are most uncertain. Right.
Yeah. That's a really good point.
Yeah, that's true.
And that sort of leads through to like one of the things where I think it is sort of key to avoiding code bloat is just designing the right abstractions. You know, if you get the abstractions right up front, then there's this kind of feeling when you're wrestling with the wrong abstraction. You just feel like the code is piling up. You're just writing all this code, and because you've got the wrong abstraction, because you're doing things the wrong way. And if you get it right, and you sort of maybe you change your abstraction and start to do things differently, and suddenly all that you can like, oh gosh, I can delete that entire package. I can delete the entire directory. I can delete hundreds of thousands of line codes sometimes, because you've changed the way it's working, and very subtle in what was initially maybe a not very obvious way.
I remember a talk about designing things for deletability, so that it's easy to delete features rather than to extend or because if it's easy to delete, then it's probably easy to replace, right?
Yep.
Yeah, I like that point actually. The on the abstraction thing, like, you know, I talk a lot about kind of avoid doing the abstractions too early. You know, let's do a few examples first and see. It'll depend on the project or the problem, but actually the real value is in these abstractions. Like, that is really probably one of the most valuable things we can do, I think. To your point, Roger, is get an abstraction right like that. If you think about a lot of the big innovations that you see, like, often it's an abstraction, and it's the right one, you know, and somehow they get it right. So that's the other thing. Like, it is very important, and practicing designing abstractions and honestly getting it wrong, like practicing and making those mistakes and living with the pain, and then you learn from that. And I think there is an element of it takes a lot of experience. Like, I don't think any of these general rules apply, you know,
if anyone wants a good exercise for practicing abstractions, like people I mentor, I usually give this exercise is you need to write temperature conversion code, right? Okay, but now you need to write it in 20 different ways, and they have to be conceptually different, like design wise, and like the different properties that they optimize for, right? For safety, for flexibility, for like ease of maintainability, for prototyping, and all these aspects. Like, and it kind of like the first 5 may become easy, and then it starts to like become more and more difficult every single step of the way. But it like makes you like think of these different ways how you can implement things. So
that'd be a
sounds
good
like
talk.
an interesting exercise.
Yeah, I'd like to see that. I'd like to see you do that, Egon, in a talk.
Then he would ruin all the future things for his mentors to learn.
True.
Oh no, I can pick any different problem. But,
yeah. Yeah, that's funny. It reminds me, the temperature thing reminds me at school. I was the first in my school. I was the first year to do IT as a GCSE, but the school just wasn't ready for it. No one really had computers. You know, they were teaching how to do spreadsheets and word processing and things. And the final, like but I was into computers from a very young age, so I really loved them. And you know, like one of the questions is, of these devices, are they? Is it an input device, a storage device, or an output device? Monitor. Let's my turn to do a quiz. Roger, monitor, is that an input, output, or a storage device?
Input and output.
You can only pick one, Roger. Otherwise, you get no
pick
points.
one.
Oh, mate,
okay.
This is not feel my pain.
Yeah. Okay. Oh no.
Well, worse was hard drive. Hard drive. It's like, how are you getting things on and off if it's not also input and output? I left those notes in the side on the exam. Of course
you did.
Yeah, pedantic. But the last question was, it just said, design or explain how you would regulate the temperature in a swimming pool. And I wrote the basic code in, you know, because I used to write basic at home. So I wrote this little basic program that did that. And I don't know, it was just like nothing was really, we didn't learn any of that at school. So of course, like, they were surprised, to say the least, but did all right. But yes, and then Egon, you made a point earlier about features, because I think that is another way to avoid bloat. And like a feature, when you imagine it, say in a website, and it shows up, it just seems like a logical thing to have. But sometimes that feature adds quite a lot of complexity to the system. And this is, so like considering the actual cost, the engineering cost, the maintenance cost really of features, I think is something that is gets overlooked a lot. And Grafana, where I am at Grafana, because all the leadership were engineers, like that is understood from the beginning. Like it's implied, that we are always thinking about that. I've worked in places that's perhaps more sales driven or product driven, and that is like a fight that you have to have. But it's such an important point, I think, for people, that like the feature, like the cost, maintenance more than how long is it going to take to build it, even, because you're maintaining it for much longer, hopefully.
And just the interact. Go on.
So one of the main issues isn't. I think one of the issues with features is that they are really hard to remove afterwards. Right? So
because people rely on them, of course.
You basically can't remove a feature when you've added it. And the other thing is that interaction between features, that also leads to code bloat, because these things are maybe non-orthogonal. You're changing this other thing in the code base, and that interacts with all these other features which have to be updated. And then there's the whole thing about, well, you're designing this feature to fit this use case, and you can narrowly fit it, or you can say, well, let's think a little bit wider here. Maybe if we make this a little bit more general, we can cover not just this use case, but also all these other potential use cases, and make like more of a very generally useful feature. And that can, and then somebody asks for a feature later, and they say, oh no, you don't need that feature because you can use this other feature that we already built. And that, I have to say, that's hugely satisfactory when that happens.
Yes.
It doesn't happen often, but
that is also a thing I think people should always ask themselves when you're considering how to solve a problem. This is why I always like it whenever use cases come in, when they focus on the problem, because it's very easy for people to write a ticket to say, oh, we need a button here that does this. This is what our customers asked for. When really, really we want to know what's the problem that they're trying to solve, and then take a step back and see, like you say, and it's like, I mean, I can think of so many examples of places where we've had that thought, we found the general one, and then it's just paid dividends again and again and again down the line. Absolutely. So I think that's great.
That whole take a step back thing is actually key throughout all of software engineering. I think don't just focus directly on what you're trying to solve. Think through the code and in the wider situation. When you're reviewing code, this code is addressing this particular problem, but maybe it doesn't need to be. If you take a step back and fix it more generally, maybe do a little bit more work now up front, but that might save you more bloat in the future.
Well, it's that time that we always have a time on Go Time, and it's this time. It's Unpopular Opinions time. It's time also for the theme tune.
I actually think you should probably leave.
Roger, would you record a fiddle accompaniment to that so that we can play it next time on?
All right, done.
Oh, that's going to be great. Thank you. And we'll get your TinyGo music machine as well, Egon, which I already have a recording of. Okay, so who's got an unpopular opinion for us today?
I think I already said it, but you should review every line. It's either direct or indirect of your dependencies with similar standards as your own code base.
See, I think that might be a good one for an unpopular one. I think that might be unpopular. So you're saying if before you import a package, read every line, and
yes.
What about its dependencies?
Those as well, of course.
And presumably every time you update to a new version, right? You have to
Yes,
review all
yes.
the changes too. Right?
Yeah. I think people like import packages assuming they are better than their code bases, right?
Yeah.
And if you have such really high standards for your own code base, why wouldn't you have those as well for like other code bases? Right?
Yeah, isn't it about responsibility? Like when you,
Yeah.
if there's a package that I sometimes there are packages out there, and they maybe have a couple of stars. They're not really used by anybody, but there are clues, there are signals to look for packages that are sort of a bit meatier and a bit more stable. Is it our responsibility?
I have to say that I don't do that. What I do tend to do is when I look at a dependency, I look through the code and say, does this look like what I would expect to find in a package that is implementing that functionality? Does it generally look good, feel about right? Is this too big for what it should be? And I, quite often say, no, let's not that have this is horrible.
Yeah, does it have tests? That's
But I to be honest, I struggle to understand my own code, let alone other code that I'm importing. So I just I've never I couldn't understand the gRPC code, the HTTP2 code. Like somebody's spent man centuries probably working on that code, and there's no way I could meaningfully review it. I don't.
Man or woman years? They years. That's the modern measure of time.
Yes. Sorry.
That's all right.
Yes. Person years.
No, yeah. Yeah. Go on, Egon. What do you reckon?
But yeah, I think it has many like benefits if you do review them, even if you don't understand them, right? Because if you're reviewing other code, you might look at how they build things. Maybe you learn something new, right? Maybe you discover some bugs that need to be fixed because you have like different expectations of the code base, right? Of course, when I say you review them with the same standard, you don't worry about the like formatting details or like they decided to use spaces instead of tabs. Like fine, like let them have those spaces.
I do. No way can they use spaces. Just absolutely no out.
But yeah, and also like there have been many attacks against like code injections and like that you should be worried about, right? So
it's one of those that's hard to argue against once somebody said it. It's like if someone says, you should have all this extra security. It's hard to say, no, we shouldn't.
I mean, I think it's hard to argue. I think it's easy to argue against because I don't think it's reasonable. I don't think it's possible for most people. I think that we should have better supply, better, dependency chain assurances, honestly.
But until then,
than we do.
I do think there is a case where you don't need to review them if you're actually paying someone else to maintain that code base. Like then you're like intentionally offsetting your own responsibility to somebody else. Like I do consider like every dependency as your own responsibility to maintain and to fix things when things go critically wrong, right?
I mean, with that rule in place, you've certainly been incentivized quite strongly not to include many dependencies. So it has that effect,
of course,
too.
Yes. Like, do you really want to review gRPC? Like,
I do now. I'm going to print it out and take it to bed.
Maybe you can make a bed out of it already.
Yeah. Nice. Okay, Roger, have you got an unpopular opinion for us?
My unpopular opinion is that I think that often just working on a laptop with just a small screen, not on my big desk with multiple monitors, mouse, etc., just my laptop with my little screen and just a keyboard, maybe just on a sofa or something, is actually more productive than working on my big desk with multiple monitors and all the stuff. So it seems that way to me.
Yeah. So is this about like there's no distractions and you're just like in that world?
I think it might be. I think I don't really understand it, to be honest, because
Hmm.
it should be that I've got all these. I can see all the things. I can do
Hmm.
all the things. I've got the nice, rising desk, all the stuff that's absolutely optimized for me, and then I can, sit on the sofa with my laptop, and suddenly the code starts to flow.
Yeah. What do you think of that, Egon? Egon, sorry. Let me do that again. They can edit it out. What do you think of that, Egon?
I do think it's nice. Like I occasionally go to coffee shops to program there, and so it's it does give you a bit more focus. So
yeah, I also wonder, Rog, if it's because most of your time has been spent there, rather than like if you think about, in the past, you didn't have all this tech and these monitors and a desk that moved up and down. By the way, instead of the sorry.
In the past, I didn't have a laptop. That's where laptops are a new thing, really.
You just have to have your computer, have your monitor on your lap.
Yeah.
If you want
It's
to
a
do
bit
that.
big and heavy, like big 17-inch thing.
By the way, instead of those desks that go up and down, it's a bit more expensive, but you can actually just have your entire floor move and same effect, have your desk fixed, and then
Actually,
just move the floor.
it's funny because I got this rising desk, which technically has 4 save positions in that, and I actually never use it anymore. I just stand. I started off and I'd stand and I'd sit. Now I might as well just got a desk of that height.
Oh yeah,
I never sit down, apart from when I'm on the sofa. Maybe that's the reason.
But why do you need 4? Because you've got standing, sitting. Is there one like when you're on your knees praying, like you're really hoping the code's going to work?
My theory is that it's for you and one other person.
Yeah, that's my theory too. But for comic effect, I pretended not to know
effect.
that. That just doesn't always work. Haha, thank you. But let me ask you this, Roger, as well. Are you a keyboard wizard type? Do you use Vim, Emacs, that kind
I
of
am
thing?
absolutely not. We might have got into this actually, because a previous unpopular opinion of mine was that Acme is the best text editor, and Acme is a radically mouse-focused text editor. So I'm not. I don't even touch type actually. I never learned, and I never went back to properly learn.
How do you get the keys to happen? You blow on them. You don't. But you refuse to touch it.
I just kind of 2-finger, very slow. Look for the key.
I knew I worked with a guy who typed with a single finger, and he was faster than me. And I've never seen anything like it since. I hadn't seen anything before.
Not even 2 hands.
Not even 2 hands.
Wow.
Single finger, 1 hand. It's just how he learned, and I've no idea why that happened. But he's optimized. It's.
I kind of 3 fingers, maybe 4, because 1 for the shift, little finger for the shift.
Oh, I assumed it was two are for someone else. Like 2 fingers for you to type, and then you've got 2 spare if you want to help out someone else's.
So I think the mouse is great. I don't like keyboard shortcuts in general.
Egon, are you what sort of editor are you into, mate?
Oh, I use 3 different ones. So
okay,
I
thought it might. I thought it wouldn't be a simple answer. Something told me. Yeah, Sublime.
I use Sublime, VS Code, and Goland. So depending on what I'm doing. So and I guess I edit the commit messages in Vim because I haven't bothered to change the default editor.
Okay, fair enough. That's fair enough. That's pretty cool. Yeah, I always wonder about these keyboard people that are amazing on the keyboards. It's like I always look up to them, but maybe it is just they're rubbish with a mouse. Like they just can't do it, and that could be that.
I actually quite like the touch point thing. So I don't use the touchpad when I do use my my laptop. I don't use the touchpad. I use this touch point thing, which is only on Lenovo's. It's just a little nipple that's in the middle, red thing, which is in the middle of the keyboard, and I think it works really well.
I do miss my touch point. So
interesting.
Yeah, so it's like a little thing with a grip on it, isn't it? And it's essentially like a joystick. It's like a tiny
joystick, except it doesn't move. You just kind of push it, and it does lose its grip after a while. After like a year or so, you have to get another one, a replacement.
Oh, you could moisturize your hands. You could.
Yeah, it's actually really bad if you're really sweaty. It can be a problem.
Awesome. Well, speaking of being really sweaty, my unpopular opinion, I've got one today. I don't understand shower gel. It's, this is that, I don't know if you've seen it or you have it. It's basically, it's like some kind of bath time slime, and it's like, it never smells great. And people have it. Sometimes I'll go to my brother's and I'll go in the shower, and he doesn't have any soap. He just has these bottles of shower gel, and it's sort of just slimy, and I don't know, never feel clean. Not happy with it. What's your stance on shower gel?
I actually tend to agree with you that not about shower gel, because I like, if you put it just all drips away. It's like it's like it doesn't. Whereas give me a bar of soap, and it's there,
Don't
right?
you
can
use
really go
a
to town.
sponge for it, or
Oh, a sponge.
something?
Sponge?
fluffy?
No.
That makes
Yeah.
sense. That does make sense, though.
I suppose that does make more sense. No,
Do you
No.
feel
maybe
the
that's
same
why.
about? Do you also feel the same about shampoo, or?
No, although I realise that is very similar. I don't have loads of hair.
I have to say that I have recently in the last couple of years changed to using bar soap for the shampoo. You can get these shampoo bar soaps, and it works really well. And you don't have that bottle which you have to throw away. So less plastic.
Yeah.
It lasts for
Nice.
ages. Actually
Sold.
works really well.
Sold.
I totally recommend it.
I want everything in a bar. I want a bar of toothpaste now. You just rub the bar in. Yeah. No, but like a shower gel, like in some places where the water's soft, like it doesn't even all properly come off. So you end up
You are
being all
like putting it
slimy.
on. You are like putting it on during the shower, not afterwards, right?
Yeah, I think I haven't read. To be fair, I've not read the label, and so I maybe use the error, but I just don't get it. I just don't like it. I like a nice rough bar of soap, something that's rugged, and you know what I mean. I'm not like one of those really manly people.
Steel wool.
Steel wool. Oh yes, please. I like a towel. Like I went to a hotel. It was a bit fancy, and the towels were all soft, and it's horrible. I want a rough towel. I want it like an elephant rubbing up against a tree, please.
Loofah.
Loofah. Yeah. Well, I'm afraid that's all the time we have. But I learned a lot, mainly about bath things, but also about code bloat. So thanks very much to my guests, Roger Peppe. Always a pleasure, Roger. Hopefully you'll come back soon.
It was a pleasure.
Yeah, and Egon Elbre.
Yeah,
Always
it's been
emotional.
awesome.
Oh yeah, good. It's been great to have you.
Yeah.
And we'll see you next time. I'll send you the unpopular opinion music, Roger, and I'll try and remember what key it's in, and then you can record.
I wasn't serious.
Oh, how cool would it be if we do unpopular opinions and it's the fiddle version?
Okay.
I actually got recently myself a tin whistle, because
I was just
Nice.
talking. I tried to learn that once upon a time because I thought it was the perfect. This is before you came on. I thought it's the perfect instrument for going climbing in the mountains with, because you can just put it. It's indestructible, cheap.
Yeah.
Yeah.
If
Also
you get,
can sound great.
yeah, and if you get lost, you can.
And
use
if
it
you
as
get lost, absolutely. Yeah.
Because they give you a whistle, don't they, when you crash on water on the plane? There's like to attract attention, and when you're 3,000 miles away from anyone, you have this little whistle. So, but yeah, you could be popping your tin whistle out. You'd be rescued first, Roger.
Yeah, I could actually. I do have a mate in the village who runs a recording studio, so I could probably get him to mix it.
Oh, this has to happen. That's so cool. If you could film it too while you're doing it, so we've got the video.
Yeah,
No
actually,
rush,
he does that too. Yeah. No, I suspect that it's not going to happen, but you never know. You never know.
I
Send me the
suspect-
music.
I suspect it is going to happen.
Actually, we'll do a folk we'll do a folk version of
Okay.
Unpopular Opinions.
Yeah.
Yeah, I've got my acoustic.
All right.
I could do that.
All right.
I don't know what key it's in, genuinely though. I think it's in that. I think it's in A.
Or I
Might
could
be
just
E.
do it with my mate who is actually a professional guitar player too. So
Only if he's better than me.
I think you might find.
Yeah. Fair enough. Sounds like a hoedown.
Oh, yeah.
Acoustic guitar off. Okay,
He also
brilliant.
plays accordion, bass, piano, all the other things. So we'll just have a regular thing going.
Yeah, we'll just have a
fun.
jamming session.
All right, let's do it.
Nice one. Right, I'm going to stop the recording now. It'll tell you how